Scientific notation. This is part 2 of the scientific notation videos. This is the individual practice answers. On the previous video, you were to write down these 3 examples and work them out on your own. So let's take a peek at the answers and check your work. Convert from standard to scientific notation. On the first example, there's an understood 0 here, and I'm going to move that decimal until I only have one non-zero number to the left of that decimal. So I would have to move it 3, 4, 5 times. So the correct answer here would be 7.05 times 10 to the 5th power. Remember, my number in standard notation is greater than 1, so I have a positive exponent. On the next example, I have a number in standard notation that is much less than 1, so I know right off the bat I'm going to have a negative exponent. Well, how many times will I have to move this decimal to get to the point where I only have one non-zero number to the left of my decimal? There's 1, 2, 3, 4, 5, 6, 7, 8, 9 times that I would have to move my decimal. So negative 9 becomes my exponent. 2.05 times 10 to the negative 9th power. Letter C. I have a number much larger than 1 in standard notation. I will have a positive exponent. So I'm going to start with my decimal. Remember, it's understood to start off over here. And I would have to move it 3, 6, 9, 12, 15 times to get to the point where I only have one non-zero number to the left of my decimal. So the correct answer here is 3.006 times 10 to the 15th power. Remember, those zeros that are between non-zero numbers, those sandwiched zeros, those stay in the coefficient, that part of the number out front. On the last 3 examples, you were supposed to go in reverse. You were supposed to take scientific notation and revert back to standard or the longer notation. On letter A, I have a negative exponent, which tells me this number in standard notation will be less than 1. So for this number to be less than 1, my decimal is going to have to move to the left 12 times. Well, I only have one number as I move to the left. As I move past it one time, I'm going to have to add 11 zeros to put this number into standard notation. So your answer should look like this. 0.000000000000034 grams. See, there's a reason we use scientific notation. On letter B, I have a positive exponent, which tells me this number is much larger than 1. So I'm going to have to move my decimal to the right in order for this number to be larger than 1 in standard notation. So I take my decimal and I can move it twice, but then I'm out of numbers. So what do I have to do for those last 2 movements? Well, I'm going to have to add 2 more zeros. So this number written out in standard notation looks like this: 40,700 liters. Notice where my decimal was to begin with, and notice where it ends up. When there's no decimal present, it's understood to be back here behind the number. So I moved my decimal 4 times. Letter C, I have a negative exponent, which tells me a very small number, less than 1. So I'm going to have to move my decimal 3 times. Which direction? To the left, in order to end up with a number less than 1. Well, I only have one number. If I move it past the 1, I need to move it 2 more places, which means I need to add 2 more zeros. This number, written in standard notation, is 0.00109 meters. You may be asking, where did that 0 out in front come from? When we write a number as a decimal, we have that 0 as a marker out in front of the 0. So it's kind of a placeholder there. Those other two zeros in front of the 1, those were the zeros that we had to move our decimal past in order to get our number in standard notation correctly. Please don't hesitate to reach out if you need help or have any further questions about these examples. Have a great day.